Why even teach this stuff? I mean, does it matter if a kid knows the difference between a whole number and a natural number? And what if they don't know the difference between the associative property and the commutative property, but they know how to do those kinds of things? What's the purpose? Education is so much more than just, obtaining a skill set or developing a body of knowledge. And math is so much more than just answer getting and computation. I've recently taken it upon myself to, challenge myself to find a way to teach the properties of real numbers and the real number line so that it serves those, lofty notions. And I'd like to take just a couple moments to talk to you about how and why to teach the real number line and properties of real numbers. One idea that you can introduce to students when you're talking about the real number line and sets of numbers is the idea of what infinity means. But there's more. Just hear me out. So first of all, students need to understand that infinite is not a number. It's an idea. Things approach infinity. Infinity is a notion. It's an idea. And I'm not even sure if it's something that actually really exists or not. It's a really interesting thing to talk about. So you could take the set of natural numbers and you could tell students, yes, these are infinite, and you can ask them to say why. Eventually, somebody's going to say, I can think of the biggest number possible, and all you've got to do is add 1 to it, and then you've got another number that's even larger. So if I say that this is the biggest number and this is where the natural numbers start, you can just add 1 and you've got a bigger number. So therefore, there isn't a largest one. It just keeps going on forever and ever. Then you could ask the students about the integers. Are the integers also infinite, and why? And they're going to come up with some similar reasons. And then here's the fun part. You could ask the students, if natural numbers are infinite and the integers are infinite, are there more of one than the other? Can an infinite set be larger than another infinite set? It's a really interesting thing for them to think about and mull over. And I like that discussion because, it kind of sheds light on math as being a topic that's not just about calculation. There's ideas at play, and they're complicated and rich ideas. They're exciting to talk about. Another interesting thing that comes up is, is math an invention or a discovery? I mean, is the order in which you add, does it matter? I mean, 5 plus 7 equals 7 plus 5. Is that always true for any real numbers? A plus B, does that equal B plus A? Why? What about subtraction? What if those numbers were integers? What if it was A plus B and B was negative? Would that be the same as B plus A? And what about A minus B? Would that be the same as B minus A? So you can explore all those things, and it can become a pretty rich topic. And then you can talk about axioms, things that you just take to be true as, because they're self-evident. Like if A equals B and B equals C, then does A equal C? How do we know? Is that something that's true? Is it something that was invented? And then one of my favorite things to talk about is, a rational number is defined as a ratio of 2 integers. Specifically, the ratio of an integer and a natural number. Some rational numbers, like 1/3 fits very nicely. They're both natural numbers, both the numerator and the denominator. They're both natural numbers. And yet, if you try to make that into a decimal, you get a non-terminating decimal. It repeats. So, we've got kind of a caveat in the definition of rational numbers for decimals that repeat or stop. But why? Why is something so clean as 1/3? Why does that make such an ugly decimal? Now, the reason why has to do with, our base 10 math. And this is a good place to introduce some math that we do that's not base 10. And those things are going to cause trouble for the students in the very near future. For example, when they start doing problems that involve distance, rate, and time, time is base 60 and base 24 and, 360. It gets very complicated. And you can't just do it on a calculator willy-nilly. For example, 32 seconds out of an hour. If you plug that into a calculator, you're going to get something that's completely wrong because calculators do base 10. So 32 over 60 would be a base 10 number on a calculator, and that's something totally different than the application of time. And that's something you can kind of tease out of this whole exploration. So I will put 2 links in the video's description. One, it discusses in greater detail the things that I've briefly mentioned in this video, and the other, it's a more traditional approach to rational numbers and all the things that need to be covered the way that I cover them. The things I'm mentioning here are kind of like some ancillary things that you can bring up when you're covering rational numbers and the real number line and all that kind of stuff. Anyway, I challenge you to take things that maybe just seem, well, kind of rote, like this is just what we do, these are just facts, and make them meaningful for students. Well, insert some questions that generate some curiosity and discussion. Always seek ways to do that kind of thing. It will make the students much more engaged. They're going to retain, they're going to understand, they're going to be able to apply things in new ways, and they're going to see both math and education as meaningful and entertaining. Anyway, I hope this video was helpful. I hope it caused you to think. I hope that you can teach the real number line and properties of real numbers in a way that excites students instead of just making them bored to tears. Because, well, quite frankly, in the past when I've taught it without doing these things, that's how it's been.
Anyone?
So if you found this video to be interesting and useful, you could really help me out. It would encourage me to make more videos if you just clicked like and subscribed. Maybe leave me a comment. And also, if you find this to have some merit and be worthy of discussion, share it with your friends. Also, visit my website, thebeardedmathman.com, where you will find other similar ideas that I express and things that I explore as I challenge myself to make math more meaningful for students. Anyway, thanks for watching.